recorded is that the very first chair, female chair of Nigerian Society of Engineering, Ilorin, also is from the department, and we want to appreciate, as I'm introducing to us, the second inaugural lecturer from the Department of Chemical Engineering, Professor Temitope Elizabeth Odetoye. Ma, you are very much welcome. Ladies and gentlemen, you are not clapping. So if we are talking chemical engineering departments of the university, today's lecture is going to be the third from the department. It means today's lecture, the 286th in the series, is the 21st from the Faculty of Engineering and Technology faculty of this university. If you like, you clap. If you like, don't clap. So the 286th in the series, the 21st from the Faculty of Engineering and Technology, the third from the Department of Chemical Engineering, the very first by a male professor from the Department of Chemical Engineering. You are not happy about that? And of course, the very first inaugural lecture from the faculty in the year 2025. So we want to congratulate every member of the faculty and every member of the department. I'd like to quickly recognize the presence of some people here. Those that time will permit me to actually introduce. I'd like to start with Professor Emeritus Musbah Adeolu Akoji. Sir, you're welcome. The former Vice Chancellor at Hikma University and Federal University of Technology, Mina. And I'm also introducing to us Professor Suleiman Olatunji Adeyemi, a former Vice Chancellor of Federal University of Technology, Fort Mina. Sir, you're welcome. Introducing also to us the Kuli and Geri of the Emirates, distinguished professor, let's say the show like we minutes. Professor Yusuf Olaolu Ali, Senior Advocate of Nigeria. Thank you very much, sir. Good to see you again. It was here less than 24 hours ago. Thank you. And to all our distinguished professors from the Faculty of Engineering, because of our time, please kindly rise for recognition. From the Faculty of Engineering, thank you, thank you. These are colleagues of the inaugural lecturer from the faculty. And I'd like to also recognize here, we have the Provost, Kwara State College of Education, Uru, Professor Mukaila Ayoda Aremu. You are very much welcome, sir. And we have Engineer Aremu, the NDA Lower River Niger Basin, former. Sir, you are very much welcome. You are recognized. Don't worry, whether they clap for you or not, you are recognized. I can see here also our former Director of Works of Base University, Engineer Bolaji Sani. Sir, you're welcome. Introducing Professor Ijaya. At the mention of Professor Ijaya, I need to define it. We have more than one Professor Ijaya in the house. We have Professor Ijaya of the Department of Economics, is here seated, sir. Our former Dean, Social Science, Faculty of Social Sciences. And so also we have Professor Adeni Ijaya of the Finance Department, former Dean, Faculty of Management Sciences, and currently a member of Council of the University. You're not clapping, ladies and gentlemen. Recognizing also the Chief Imam, University of Ilorin, Professor Nasir Abdusalam. You're welcome, sir. I can see Professor Koro from Industrial Chemistry. You're very much welcome. The Chief Ekungba, you're welcome, sir. Dr. Olariwaju of Olariwaju Hospital, you're also very much welcome, sir. I recognize also Professor Abdul Wahab Olariwaju is former university librarian and currently the chairman, Library and Publications of the university. Recognizing also Professor Taiwo Yusuf from Education. You're welcome, man. Recognizing Dr. Oye Kunle. You're welcome from CIS. We have Mama Engineer, Deputy Director Works. You're also very much welcome, man. And we have also Dr. Foluke Aliyu. You're also very much welcome. And ladies and gentlemen, we have the Amoloye girls in the house. We have the leader of the girls here. Please, let's appreciate Mama Amoloye. Well, Professor Abdulaziz Muhammad Lawal, you're very much welcome, sir, from the Faculty of Agric. I will introduce him more than that for security reasons for now. Please, let's appreciate him. You don't need to see his face, just appreciate him. Because this is the time. We don't want you to trouble him too much. You're welcome, sir. Our Director, Ilorin Sugar Research, Professor Betsy Uzogu, you're very much welcome. You're welcome, madam. Oh, good to see you. Mama. So good to see Mama Johnson in the house. Ma, you're very much welcome. Where is Daddy? We can see also the First Lady at Hikma University. Ahaja Oladimeji, you're very much welcome. Don't worry, whether they clap for you or not. Don't worry. Yeah. They don't clap so much in engineering. Most especially when they are from afar, they don't. Our council member, our distinguished council member, FNIPR, Alhaji, you are very much welcome and congratulations on the World PR Day yesterday. Congratulations. And congratulations again on the emergence of a distinguished member of the council as one of our deans in this university. You're welcome, sir. So, ladies and gentlemen, once again, we want to welcome all of you coming around today to be a part of this. And you've not been clapping, but you must clap now. Introducing to you the First Lady, University of Ilorin, Hajia Adiola Muibat Egbewale. You're welcome, madam. You still didn't clap very well. You're very much welcome. So, talking inaugural lectures, it seems time will permit us to talk a little about this. As I said earlier, it's an opportunity for our professors to come to the forum, lead their colleagues, the university community, and the general society know about their works. But time will not permit us beyond this. Ladies and gentlemen, shall we rise to welcome the procession of the Vice Chancellor. Please do not stand in the way of the procession. Do not cross the procession. And do not exchange pleasantries with the procession. We remain standing, ladies and gentlemen, as we observe the university anthem. Please be seated.
The Deputy Vice Chancellors, the Registrar, the University Librarian, the Provost, Deans of various faculties, Heads of departments, Professors, distinguished ladies and gentlemen. It's indeed our pleasure to welcome all of you to the 286th Inaugural Lecture titled Waste Streams and Emissions Management for Sustainable Development, to be delivered by Professor Rafiu Olasukami Yusuf of the Department of Chemical Engineering. Professor Yusuf. Professor Rafiu Olasukami Yusuf was born on 18th November 1955 in Nkaka, Eastern Region of Ghana. He is an indigene of Ofa, of a local government area of Kwara State. He started his primary and middle education at St. Stephen's Anglican Primary School in Nkaka, Ghana, and graduated with distinction in 1969. He thereafter attended Ofa Grammar School between 1971 and 1975. He enrolled in the School of Basic Studies, Kwara State College of Technology in 1975 for his GC Advanced Level Examination, moderated by the University of Cambridge, and graduated in 1977. He gained admission into the University of Lagos, Akoka, to study Lautech as an assistant lecturer in 2001 before joining the University of Ilorin in the Department of Chemical Engineering as a lecturer too in 2008, and rose through the ranks to become a professor of chemical engineering in 2022. Before joining the services of the University of Ilorin, he also worked at Kwara State Education Management Board in 1982. He left for the Nigerian paper mill Jeba in 1985, where he rose to become a senior process engineer before leaving for the Cement Company of Northern Nigeria, PLC Sokoto, as a senior production engineer in 1991. He became a production engineer and a shift manager before resigning in 2001 to join academics. Professor Yusuf has successfully supervised several undergraduate and postgraduate students. He is a member of many learned and professional bodies, and these include fellow Nigerian Society of Chemical Engineers, member Nigerian Society of Engineers. He has served in various capacities and outside university, and these include acting head of the Department of Chemical Engineering 2014 to 2016, level advisor at the Department of Chemical Engineering, Lautech 2001 to 2008, Deputy State Coordinator Islamic Welfare Foundation, Kwara State 2021 to date, member Technical Committee Oyo Osun Kwara Chapter of Nigerian Society of Chemical Engineer 2019 to date, member Low Carbon Cities Research Group, UTH Johor Bahru, Malaysia 2010 to 2013, assistant auditor Nigerian Society of Engineers, Sokoto branch 1997 to 2001, to mention but a few. Professor Yusuf is a recipient of several academic awards, which include award of full scholarship for secondary school education by the Common Entrance Board 1975, International Doctoral Fellowship in 2009. He has over 60 publications in reputable home-based national and international journals, edited conference proceedings and chapters in books. He has served as external examiner to many universities across Nigeria. He has also attended many conferences, workshops, and seminars. He started the process for the establishment of the postgraduate program in the department and has the honor of producing his first PhD graduate from the Department of Chemical Engineering. Professor Rafiu Olasukami Yusuf enjoys playing, watching and coaching football, reading and network marketing. He is happily married to engineer Muslimat Funmilayo Yusuf, and the union is blessed with children and grandchildren. Welcome, Professor Yusuf, to deliver the 296th inaugural lecture. Congratulations.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي واجعل وزيرا من أهلي هارون أخي اشدد به أزري وأشركه في أمري كي نسبحك كثيرا ونذكرك كثيرا إنك كنت بنا بصيرا قل قد أوتيت سؤلك يا موسى. I seek refuge in Allah against the accursed devil. I begin the delivery of this inaugural lecture in the name of Allah, the gracious, ever merciful. Allah, you are the omnipotent and omnipresent, the first and the last, the first without any beginning, and the one to ever exist without any point of termination. It is with much gratitude to the Almighty Allah that I am here today before this distinguished audience from far and wide to deliver the 286th inaugural lecture of this citadel of learning, the University of Ilorin, which is the third by a professor of chemical engineering from the Department of Chemical Engineering. The first lecture was delivered by Professor Omadele Eleta on September 2, 2021, titled Bad Yet Good, Rummaging and Combating for Future Water and Land Security. The second lecture was delivered by Professor Temitope Odedoye on April 4, 2024, titled Symphony of Biomass, Bioenergy and Bioproducts for Sustainability. Today's lecture marks a significant milestone in my career as I delivered the 286th lecture of the university as a professor of chemical engineering in the department. This occasion is of great personal achievement and an opportunity to reflect on the contributions I've made to the field of waste streams and emissions management, both in Nigeria and beyond. I hope that by sharing my insights and experiences, I can inspire future generations of engineers to champion sustainable development and advocate for responsible environmental management. I was born many years ago in Ghana, and I started my education at St. Stephen's Anglican School from 1960 to 69. I took the Ghana Common Entrance examination in 1969, and I gained admission to 2 secondary schools and 1 technical school. But as fate will have it, some wise men advised my father against sending me to secondary school and that I should be made to learn a trade. That was how I became a watch repairer apprentice in August 1969. Fortunately, fate intervened again in that same year when the government of Professor K. Busia asked all foreigners without valid resident permit to leave Ghana within 2 weeks. It was a period of total chaos. On December 14, 1969, my family left Ghana and got to Offa on December 16 of the same year, spending the nights of 14 and 15 in Aflao and Abeokuta. I wanted to continue my education at the secondary level, but another wise man in Offa told my father that there are differences in the educational systems of Ghana and Nigeria, and that I should be made to go back to primary school to familiarize myself with the Nigerian education system. So I had to go back to Yeroakin African School in 1970, where I sat again for the common entrance. I gained admission to Offa Grammar School in 1971, and a week to resumption, I received a letter of award of full scholarship for my secondary education based on my performance in the common entrance self-examination. I passed out in 1975 the West African School Certificate examination with distinction, and I was in the School of Basic Studies, Kwara State College of Technology, as it was known then, from 75 to 77. I sat for the GCE Advanced Level Examination in Mathematics, Physics, and Chemistry, and I was admitted to the University of Lagos in 1977. I finished in 1981 and did my national service in 1981-1982 at the West African Breweries in Abeokuta. After my service, I began my career with the Kwara State Education Management Board from 1982 to 1985. On July 17, 1985 precisely, I reported at the Nigerian paper mill Jeba as a paper production superintendent. Exactly 40 years later today, I am standing before this distinguished audience as a professor of chemical engineering. Which of the favors of Allah will I deny? I left the Nigerian paper mill in September 1991 and joined the cement company of Northern Nigeria and Sokoto, where I rose through the ranks to become a chief manager. I resigned in 2001 to embark on an academic career, joining Ladoke at Akintola University as an assistant lecturer. In 2008, I moved to the University of Ilorin as lecturer 2 upon the establishment of the Department of Chemical Engineering. My decision to study chemical engineering was no accident, but a dream fulfilled and a struggle tenaciously pursued. Back in 1973, I was in Form 3 in Ofagan School at that time when chemical engineering was first introduced at the University of Lagos. It was there that I saw an image, later to be revealed as a fluid catalytic cracking unit of a refinery that showcased where a chemical engineering works. There and there I made up my mind to study that discipline so that I could work in the refinery, but I never did. The nearest I came was attending an interview in 1991 where I was asked, "Who sponsored you?" By then, I was comfortably working in the cement company of Northern Nigeria, so I jettisoned the idea. Introduction. Mr. Vice Chancellor, sir, my academic journey, which began at the University of Lagos in 1981, showed me a lot of guardians under esteemed professors, including Professor A.F. Ogbuye, Professor A. Suzu, and other lecturers in the department. And it laid a promising foundation from a passion for environmental conservation and management. Their tutelage emphasized the practical application of scientific theories and the manipulation of natural phenomena, thus sparking my interest in sustainable practices. My undergraduate project, titled Possible Energy Derivation from Lagos Municipal Refuse, was taken under the supervision of the late Professor J.O. Edewo, whose mentorship inspired my journey into academia. In 1999, I obtained a postgraduate diploma in management from Usman Danfodio University, Sokoto, and this program honed my administrative skills and highlighted the importance of effective management in engineering projects. Building on this, I pursued a master's degree program in chemical engineering at OAU Ife, which I completed in 2008 with distinction. My master's research under Professor B.O. Solomon focused on bioremediation of ternary wastewater using microorganisms. This work deepened my appreciation of the indispensable role of microorganisms in environmental remediation. During the period, I had the privilege of practical environmental engineering under the tutelage and mentorship of Professor S. Adeyemi of Civil Engineering, where I actively contributed to the design of an industrial wastewater treatment facility in Kaduna and an integrated solid waste management facility for Ilorin. In 2013, I obtained my PhD in environmental engineering. My doctoral research focused on methane emission inventory and forecasting, equipping me with the needed expertise to deal with sustainable emission mitigation strategies, greenhouse gas chemistry, and climate change impacts. By the end of my PhD program, I had gained comprehensive knowledge and practical exposure in sustainable waste management across various media like land, water, and air, and their respective control systems. Methane emission and renewable energy. Vice Chancellor, sir, the rising trend in the temperature of the earth has become a global threat. This is as a result of global warming. Global warming is caused by the emission of greenhouse gases into the atmosphere, and this has had significant impact on the world's climate. The major greenhouse gases are carbon dioxide, methane, and nitrous oxide. Records show that only carbon dioxide received detailed investigation, but not methane. Hence, a detailed study of methane emission sources was carried out. The principal sources of methane emission were identified as crude oil production, livestock rearing, wastewater, municipal solid waste, coal mining, and rice production. Comprehensive methane emission inventories for both Malaysia and Nigeria were developed as shown in figures 1 to 4, and these have informed national greenhouse gas mitigation policies. Yusuf et al. 2012, Yusuf et al. 2016. A similar work on livestock methane emission forecast from 5 decades of livestock production in Nigeria is shown in Table 1. The study employed diverse methodologies, including the Intergovernmental Panel on Climate Change, IPCC guidelines, the global standard for methane emission estimation. These methodologies have been adopted to develop region-specific emission inventories suitable for different industrial contexts, particularly in Malaysia and Nigeria. A key innovation in the research has been the application of the auto-regressive integrated moving average (ARIMA) model for forecasting methane emission. Yusuf et al. 2014, Yusuf et al. 2016. This statistical tool enables precise projections based on historical data, making it an invaluable resource for policymakers. Furthermore, biogas estimation models have been used that incorporate waste composition analysis, thereby enhancing the accuracy of methane generation potential assessments. Non-methane gaseous pollutants from liquefied natural gas operations. Mr. Vice Chancellor, the environmental impacts of non-methane gaseous pollutants from liquefied natural gas operations were extensively examined. This area is essential for understanding the broader implications of LNG production and consumption on air quality and climate change. Adenina, Yusuf, Jimada et al. 2016. Key pollutant investigated include carbon monoxide, volatile organic compounds, and nitrogen oxide that are emitted during energy processing and transportation. Beyond emission characterization, the study predicted maximum ground level concentration impact of air pollutants on ambient air quality using different scenarios as presented in Table 3, and modeled the expression of annual pollutant concentrations of CO, NOx, and VOCs as shown in Figure 6. Adenina, Yusuf et al. 2016. In the studies on non-methane gaseous pollutants, comprehensive methodologies were used to quantify emissions and assess air quality impacts. One notable approach involved the use of air quality modeling techniques, particularly the American Meteorological Society and Environmental Protection Agency Regulatory Model, AMOD, which has been instrumental to predicting ground level pollutant concentration across various operational scenarios. This framework has provided robust assessment of the potential impacts of LNG facilities on surrounding communities. Adenina Yusuf et al., 2016. Urban air pollution. Vice Chancellor, sir. My study on urban air pollution has fostered extensive collaboration across disciplines and institutions, cutting across several areas of interest, which encompass measurement, monitoring, modeling, and management of air pollutant emission, such as gaseous pollutants and particulate matter, heavy metal, also known as potentially toxic element, PTEs, polycyclic aromatic hydrocarbons, PAH, and polychlorinated biphenyls from urban traffic, university campus, markets, scrap iron industry, and thermal plants. Furthermore, my work has contributed to the quantification and prediction of sectorial pollutant emission in Nigeria from 1980 to 2015 and the understanding of air quality trends during COVID-19. Traffic-related air pollutant traps. Concentration variation of traffic-related air pollutants at traffic intersections in Ibadan, Nigeria was investigated as shown in Figure 7. Adedina and Yusuf, 2023A, investigated the concentration variations of gaseous pollutants, CONO2, SO2NH3, and TBO6, and ground level ozone, and particulate matter during the rainy and dry seasons at and around 25 traffic intersections, which are major traffic hotspots within Ibadan metropolis, figures 8 and 9. The daily rush and non-rush hour concentration of pollutants were monitored. Cancer risks and epidemiology-based mortality estimates using relative risk and attributed fractions linked with PM2.5 and PM10 exposure were evaluated. The non-cancer risks via inhalation concentration of the PMs in the dry season were found to be higher than in the rainy season. Health risk assessment over the study period showed that cancer risk via inhalation of PM2.5 was tolerable, while hazard quotient via inhalation of SO2 was above 1, indicating significant non-cancer risk and traffic intersections in Ibadan. Adedina and Yusuf, 2023B, reported seasonal variation and health risk of particulates at the 25 traffic intersections in Ibadan metropolis. The 24-hour mean concentration of the particulate matter sampled at the 25 TIS in Ibadan during the rainy season were as shown, and they were very high, corresponding in relation to the values obtained in the rainy season. The statutory limit breach (SLB) values were above the set standard of regulatory agencies at several TIs. Total respiratory deposition doses of the particulate matter were higher during the dry season by the percentages shown than those during the rainy season. Adedina and Yusuf, 2024, employed air mode model to examine traps dispersion at 25 selected TIs, considered as volume sources. Seasonal concentration of 6 pollutants, CO2, NO2, SO2, TBOC, PM2.5 and 2M, PM10 were determined using meteorological, topographical, and pollutant emission rates in air mode. Estimated peak concentration of the study pollutants were generally higher in the rainy season than the dry season, surpassing the air quality standards set by the World Health Organization and the Nigerian National Environmental Standard and Regulation Enforcement Agency, NESRI, during the rainy and dry season, except SO2, which did not exceed NESRI standard. Similarly, Adedina and Yusuf et al., 2021, studied the contamination levels, sources, and health risks of 10 potentially toxic elements at 25 traffic hotspots. The possible sources of the potentially toxic element were identified and quantified by combining positive matrix factorization with existing and new contamination indices. The results shown in Figure 10 identify 6 main sources, each contributing to PTE's pollution during the rainy and dry season. The contamination levels of cadmium and lead were more serious than those of other PTEs during the 2 season studies. Non-carcinogenic risks posed by lead and cadmium were significant in children and adults at 2 sampling sites. The carcinogenic risks of cadmium were unacceptable at some sites during both seasons. These studies show that children were more prone to both non-carcinogenic and carcinogenic hazards. Figure 12. The study provided information to prevent and control exposure to road dust pollution in a typical African city. Moreover, Yusuf et al. 2022 explored the spatial and seasonal pattern, sources, and related cancer health rates of pH in the road dust sampled at the 10 spots. Mixed pH sources were ascertained using the diagnostic ratios and PMF model. The results show that 3 rings pH were the most abundant pH, with anthracene being the predominant pollutant in Ibadan. Benzo-K-fluorantine, BKF, which is a pointer of tracheal emission, was the most dominant among the 7 carcinogenic pHs considered. Seasonal variation results show that pH concentration were 20% higher during the dry season than the rainy season. Quantifications and predictions of air emissions. Abdulrahim Adenina Aremu Yusuf et al. 2023 developed a comprehensive sectoral emission inventory using the emission factor approach to estimate various pollutant emissions from different sources. 5 major sources of pollutant emissions were identified, which include transportation, energy, municipal solid waste, wood fuel, and agricultural sectors. An increased trend in emission from 1980 to 2020 was observed for total emission of CO, NOx, PM2.5, PM10, SO2 NOx, ammonia, and non-methane volatile organic compounds in Nigeria. See Figure 14. This report reported that wood fuel, transportation, and municipal solid waste sectors are the major sources contributing high percentage in the total carbon monoxide emissions. 3 mitigation scenarios for emission reduction for the future were analyzed. These scenarios were liquefied petroleum gas intervention, waste to energy technology, and vehicle inspection and maintenance policy scenarios. When these scenarios were simulated, reductions of 38%, 24%, and 38% respectively were observed. Air pollution during COVID-19 pandemic. Mr. Vice Chancellor, sir. Odedina Yusuf and Adenina 2022 investigated the trends and sources of air pollution at traffic intersections before and during the COVID-19 lockdown in Ibadan, Nigeria. The relationships among climatic parameters, vehicular counts, and 10 air pollutants, which include particulate matter and gaseous pollutants and ground level ozone, were measured simultaneously at the traffic intersection and were analyzed. Results indicated that significant decrease in mean concentration of all the pollutants studied were observed, except NO2, which had a 212% increase during the study period. Concentrations of the other gaseous pollutants were found to be reduced during the lockdown. An integrated source apportionment approach using Pearson correlation, airflow backward trajectory, high split, and principal component analysis identified vehicular emission as the primary source of studied air pollutants at traffic intersections before and during the lockdown in Ibadan. In addition, Adenina Muniru, Oloride Sonibare Yusuf, Abraham Odedina Yusuf, and Sonibare explored indoor transmission dynamics of expired COVID mask in a model African hospital ward by studying the cough and sneeze droplet interactions with indoor air of a typical hospital clinic that are mostly found in developing African countries. This work investigated the effectiveness of existing guidelines and protocols being adopted in the control of the spread of coronavirus disease. The influences of indoor air velocity, the type, size distribution, residence time in the air, trajectory of the droplet were all considered while investigating the effectiveness of physical distancing measures, the use of face covers, cautionary activities of the general public, and the plausibility of community spread of the virus through airborne transmission. As shown in Figure 15, a series of models were implemented in the numerical studies. Based on the district-based models, concentration as function of particle distribution and particle distance time that were observed on the different droplet points, the virus droplets were found to travel several meters away from the source of release, that's the index patient, with smaller size droplets staying longer in the air. The behavior of indoor air was also found to indicate complex dynamics, as particle transport showed no linear dependence on air velocity. Air pollutants from scrap iron recycling plants. That's country of thought. The growing demand for ferrous metals and abundant scrap metals have fueled Nigeria's scrap iron industry, leading to hazardous pollutant emissions. Therefore, Ogunlade, Adenina Ibrahim, Odedina Atande Oyeneya Akapo and Yusuf, 2024, investigated pollution levels, sources, and health risk of 10 potentially toxic elements, as shown in indoor and outdoor areas surrounding a major scrap iron recycling plant in north-central Nigeria. The potential studies of the toxic elements, pollution during the rainy and dry season were evaluated using positive matrix factorization model. Ecological risk assessment of study features were conducted using different pollution indices. Out of the 10 toxic elements studied, cadmium had the highest pollution level and exhibited a high potential to cause cancer in children. During the 2 seasons considered, Figure 16 presents the identified sources of the toxic element for rainy and dry season. This study contributes to the understanding of the environmental impact of scrap iron smelting operations and advocates for the implementation of sustainable practices that protect both human health and the environment. Mr. Chancellor, sir, in this question again, Adenina Ogunlade Odedina Yusuf and Sonibare 2024 studied the concentrations, seasonal and indoor-outdoor variations, origins and health impact of polycyclic aromatic hydrocarbons in dust samples around a scrap iron smelting facility. Analysis of dust samples revealed that high molecular weight polycyclic aromatic hydrocarbons dominated during both seasons, with 5-ring pH 34% contributing more during the rainy season and 3-ring pH 36% dominating during the dry season, as shown in Figure 17. Carcinogenic pH were more prevalent in the rainy season compared to the dry season. 7 pH sources were identified, with gasoline combustion being the dominant source during the rainy season and iron and steel production being the dominant during the dry season. Incremental lifetime cancer risk assessment show pH concentration within safe limit, with dermal contact limit identified as the primary source exposure pathway for both children and adults in the study area. Air pollutants from thermal plants. Adesami Adenina Pakile, Jimada Yusuf, and Sonibare 2016 carried out studies on air pollutants from thermal plants, focusing primarily on emissions, characterization, and their implications for air quality and public health. at both local and national levels. This area of study is particularly critical given the reliance on thermal energy generation in Nigeria and globally. Key pollutant investigations include sulfur dioxide, nitrogen oxide, particulate matter, and volatile organic compounds. The sources and chemical composition of these pollutants, their atmospheric dispersion dynamics, and their effects on human health and their environment were rigorously pursued. The findings revealed alarmingly high levels of sulfur dioxide and nitrogen oxide in the vicinity and surrounding areas of these facilities, the concentration exceeding both national and international air quality standards. These findings reiterate the pressing need for more rigorous monitoring and control measures to mitigate the health and environmental risks associated with thermal plant emissions. Bioremediation of polluted soil. The studies conducted on bioremediation were focused on characterization and restoring polluted soils contaminated by anthropogenic activities that include petroleum spill, industrial discharges, and agricultural runoff. Olu Arotiova, Yusuf, and Adelowo Emota, 2008. Agari, Durojaye, Yusuf, Aremu Solomon and Majid, 2008. Agari, Owabo and Yusuf, 2010A. Agari, Owabo and Yusuf, 2010B. Agari, Owabo and Yusuf, 2012. Yusuf et al., 2022. This area is critical for assessing environmental degradation and promoting sustainable land use practice. The studies concentrated on the application of microbial and phytoremediation techniques to restore contaminated sites effectively. Microbial remediation utilizes either naturally occurring or engineered microorganisms to degrade pollutants, while phytoremediation involves the use of specific plants capable of absorbing, accumulating, and detoxifying contaminants. The investigation into bioremediation techniques have employed a range of methodologies specifically aimed at addressing diverse contaminants and varying soil conditions. Another milestone reached in the research work is the integration of phytoremediation with microbial bioremediation. Yusuf, Amaloye, Adenira et al., 2022, tables 4 and figure 18. This hybrid approach is quite interesting as it employs specific plants to stabilize, extract, and detoxify contaminants, while simultaneously leveraging microbial activity in the rhizosphere to degrade pollutants. I have studied different plant species that enhance the bioavailability of contaminants to microbial communities, thereby facilitating more efficient remediation process. This integrated strategy has much proven to improve cleanup efficiency and provide a sustainable and environmentally friendly alternative for managing contaminating sites. Solid waste management and material recovery. Vice Chancellor, sir, my research in solid waste management primarily focuses on addressing the growing challenges associated with waste generation, particularly in urban areas, while equally promoting key components of the United Nations Sustainable Development Goals. Abba, Nur Yusuf et al., 2013. Lee Nur Yusuf et al., 2017. Nur Yusuf Abba et al., 2013. Usman, Nur Abba Yusuf, and Hassan, 2013. This work encompasses several key areas that include waste characterization, that is analyzing the composition of solid waste to identify opportunities for energy and material recovery. Energy recovery technologies, exploring methods such as anaerobic digestion, incineration, and gasification to convert waste into energy. Recycling and material recovery, investigating efficient recycling processes to recover valuable materials from waste stream. Policy and regulatory framework, evaluating existing waste management policies and recommending improvement to promote sustainable practices. Many innovative solutions have been developed through these research areas that conform to the principles of the circular economy, where waste is minimized and resources are recovered and reuse. In the investigation of solid waste management for energy and material recovery, I employ diverse methodologies similar to specific waste type and recovery technologies. One significant innovation has been the development of comprehensive waste management framework that integrates waste characterization, energy recovery, and recycling processing. This holistic approach ensures the efficient use of resources and minimizes environmental impact. Additionally, I have used data analytics and modeling techniques to optimize waste management process. For example, I developed predictive models to forecast waste generation rates and their potential for energy recovery based on historical data and socioeconomic trends. Yusuf and Oyewumi, 2008. Yusuf et al., 2008. No, Yusuf et al., 2017. No, Yusuf et al., 2013. Abba, no, Yusuf et al., 2013. Lee, no, Yusuf et al., 2017. These models provide valuable knowledge for urban planners and waste management authorities in designing efficient systems. Another area of focus has been the optimization of anaerobic digestion processes to enhance biogas production from organic waste. Yusuf et al. 2019 and Yusuf et al. 2019. My research presented the yearly and cumulative gas production rates and cumulative gas production as shown in Figure 20. By exploring various feedstock combinations and process parameters, I have identified strategies to maximize energy recovery while minimizing greenhouse gas emissions. Environmental impact and life cycle assessment of processes. Vice Chancellor, sir. The research in this area has significantly focused on environmental impact assessment and life cycle assessment methods, particularly concerning industrial processes in areas such as methane emissions, air pollution from thermal plants, bioremediation of pollutants, and solid waste management. These methodologies are important for understanding the environmental consequences of industrial activities and identifying opportunities for improvement and mitigation. In these investigations, comprehensive framework that integrate EIA and SCA to holistically assess the sustainability of industrial processes were developed. This allows for simultaneous evaluation of resource utilization and environmental impact, thereby offering a clearer understanding of environmental performance.